Okay, so the first example that we've got for hypothesis testing is given here, and it's a manufacturer of a new type of seeding compost. Exciting. And what they're saying is that their compost, their new compost, is super compost, and that it's going to have a higher germination rate than regular compost. So remember, germination is just seeds turning into plants, not turning German. So if they were sown in ordinary compost, then a particular variety of seed will have a germination rate of 70%. So in regular compost, 70% of seeds turn into flowers, and this manufacturer is saying that their new super compost is going to lead to more seeds turning into flowers in their new super compost. To test the manufacturer's claim, an experiment was conducted. So they planted 20 seeds in this new compost, and they found out actually that 18 of the seeds germinated. So is that more than what we would expect? And if so, is that a lot more than what we would expect? So these steps. So to conduct a hypothesis test, the first thing that we need are hypotheses. We call our null hypothesis, so this is our regular scenario, our original assumption. So for us, in this case, the null hypothesis then is the standard compost. Okay, so regular compost has a probability of 0.7 getting a seed into a flower. And the alternative then is the new claim. What are we looking for? We want to know, or is the proportion greater than 70%? Is this compost actually a lot better than the regular compost? So they are our hypotheses. We then decide on a significance level. Well, there's nothing mentioned here about a significance level, so we will usually call it 5%. Now the significance level, if you remember, is the probability at which we say, okay, anything smaller than this, any probability lower than this is too unlikely. And so if we end up with a probability smaller than this, that's our kind of cut-off point when we are testing later, usually 5%. We then collect suitable data using a random sampling procedure. Well, we didn't need to really do that because the question did it for us. And if I just turn this baby monitor off, sorry, before he starts crying. There we go. So we collect suitable data using random sampling. Well, they did that for us. So they said, okay, what are we going to test? Our test statistic, which is X, is the number of seeds germinating. That's what are we counting? Well, we're counting the number of seeds germinating. Our test statistic. And then our sample size was 20. We planted 20 seeds, and the number of seeds that germinated was 18. So that gives us then a binomial distribution. X squiggle B. N is 20. And we would expect at the regular conditions 0.7 of them to germinate. So again, for a hypothesis test, we assume that this is just regular compost because we know information about regular compost. So we assume that it's regular compost there, and now then we are going to see, okay, this sample that I just got, we're 18 out of 20 germinated. How likely is that to happen if this were just regular compost? Is this actually normal? Do 18 out of 20 germinate in regular compost quite often? If they do, well, the manufacturer, sorry, I mean, your compost isn't that good. So that's the information that we got from the question. What we are counting, which is the number of seeds germinating, how many of them we planted, and how many of them did germinate, so we can work out their binomial distribution. We can also, as well, which is quite good to know, is see, okay, in regular compost, how many would I expect out of those 20? Well, I would expect my expected value of x, I would expect 70%. So 14 of those 20 I would expect to germinate, which is pretty handy because actually, yes, 18 germinated. Also, that is more than I would expect. But is there a lot more than I would expect? Oh, I don't know. I don't know yet. So what we do then to conduct the test is we calculate the p-value, which is the probability of getting my sample or even more extreme. So we always include the more extreme. So in this case, that's the probability that x is 18 or even greater than 18, even further away from what I was expecting. So another tip is maybe H1 there, whatever symbol in H1 is, it has to be included in your p-value there, your probability. So what is the probability of 18 or more seeds out of 20 germinating in regular compost? If I assume this distribution, so regular compost, what is the probability of the sample that I just got happening? Is it quite likely or is it not? Oh, well, I can work out that probability from my tables. It comes out as 1 minus 0.9645, which is a probability of 0.0355. That is small, so 3.5%. That's my p-value. That's the probability of my sample, or even more extreme than my sample, happening. I mean, if 18 seeds out of 20 germinate, and if I want to say, oh yeah, that's super compost because that's a lot more than 14. Well, if 19 seeds or 20 seeds, well, that just means it's even better. So I always include the more extreme bits. So the probability of 18 or more seeds germinating was 0.0355, which is quite small. It's smaller than my cutoff point, which is the significance level there. Therefore, I have decided that this is highly unlikely. It is highly unlikely for this to be regular compost if 18 or more of them germinate, 18 or more of these seeds germinate. So therefore, we have enough evidence, so I would say that there is strong evidence to reject the null hypothesis, which is the original compost, that the proportion of seeds that germinate is 70%. I've got strong evidence to reject it because under those conditions, you're not going to get 18 or more germinating in regular compost out of 20. It's just too unlikely. Look at that. Look at the probability of it happening. It's too unlikely. So I would say, okay, that is strong evidence to reject the null hypothesis. So therefore, it's more likely we can assume that probably the proportion of seeds germinating in this new compost is probably higher, or likely to be higher. So the problem is that the reason that this probability of my sample happening is so low is because I was expecting 14 to germinate. I probably should have been expecting more to germinate in the first place, meaning that the proportion should have been higher. So that's my H1. So try not to say that you accept H1, because it doesn't prove H1 is true. It's just more likely to be true than H naught is. Again, it's quite a small sample size, but yeah, the probability of 18 or more germinating is very, very small. So that is our first hypothesis test. So just a quick run through of what we just did. Set up our null and alternative hypothesis, then decide on a cutoff point, a significance level. That's the probability that you want to be less than. That's when you start saying, yeah, okay, this is too unlikely. It's too unlikely for H naught to be true. Then collect some data. So the data is collecting the number of seeds germinating, how many did we plant, how many germinated, so what does our binomial distribution look like. Then what's the probability then under H naught, so just assume this is the same old regular compost. What's the probability of my sample, or even more extreme than my sample, happening? Oh, it's very small. The likelihood of me just planting 20 seeds in ordinary compost and 18 of them germinating, or even more than 18 germinating, is tiny. So under H naught, that's just regular compost. Then that's too unlikely to be regular compost, so it must be some sort of super compost. So we do have evidence to reject H naught. Again, that doesn't say that it's definite, because it's still a 0.0355 chance that H naught is true, though this is regular compost. We just think that that's too unlikely. So therefore, the proportion of seeds germinating in the new compost is probably higher than 0.7. We should have been expecting more to germinate in the first place. Thank you.